Let's take a look at some rules for differentiation. And I'm going to write them down here. Now the first one is this is notation for derivative, the derivative with respect to x. If we're taking derivative of a constant, and I'll put c there, derivative of like a 5 or 7 or negative 2, the derivative of a constant is always 0. Now if you have a constant and then a single x, like 5x or 7x or negative 2x, your x just disappears and your derivative is the number in front, the c. And then if you got x to a power, take your power, put it out in front, lower it by 1. So the derivative of x to the n would be n times x to the n minus 1. Now actually the second formula is just a variation of this one. So technically you don't need that one because this is covered by it, but it does help to have that. Now let's look at some problems. Last section we looked at how to do it the long way, so here we're using a shortcut. Got h of x is equal to 4x to the third. And it says find derivative of the function. Now if you have numbers out in front of your x, those just stay out in front. So those don't change at all. So I'll take the 4, leave it out there, and we have x to a power. Well, this says we put our power out in front, and then we lower it by 1. So put the 3 out in front, and then we lower it by 1. So that gives us 12x squared. And that's our answer. Let's see, y is equal to 3x to the third minus x squared plus 7x and plus 5. Now if you got multiple terms, what you do is you just take the derivative of each one separately. So our first one here, 3x to the third, the 3 stays out in front. Take my power, which is 3, put it out in front, and lower it by 1. Now the negative x squared, negative stays out in front, take our power, put it out in front, lower it by 1. Now if we have a number with an x, again the x drops away, so that becomes 7, and then derivative of 5 is 0. Which gives us 9x squared minus 2x plus 7. And that's our answer. This one we got h of x is equal to x to the 3/2. Now this does not say they have to be nice integers or anything. No matter what the power is, you do it. Unless it's a variable. Okay, so our property says take your power, put it out in front, and lower it by 1. So we got 3/2 out in front, and then our power becomes 3/2 minus 1. Well, this is a mixed number. So the negative 1 here, you can take negative 1 times the 2. That gives you a negative 2, and add the number on top, which is 3. So that gives us a positive 1/2. Again, I took the number out in front here, or out and back. Negative 1 times 2 times the denominator. That gives us just negative 2, and add the numerator, number on top, and that gives us a positive 1. Let's take a look at this one. We've got g of x is equal 5th root of x plus 3. Now we don't have any property dealing with radicals, so what we want to do is we want to write this in fractional power form. This 5th root of x would be x to the 1/5, and then plus 3. Now whatever number's in your little slot here, that's your index, that goes in your denominator. Whatever power is inside here, and there isn't a power here, but if I were to put 1, it'd be like the invisible 1. That goes up in your numerator. So then we're ready to do our derivative, because everything's x to a power or a number. Well, our property says take your power, put it out in front, and lower it by 1. And then derivative of a number is just 0, so that drops away. Well, this gives us 1/5, x to the 1/5 minus 1. Again, this is a mixed number. I can take the negative 1 here, multiply times the 5. That gives you a negative 5, and add the 4, and that gives you a negative 4/5. If you stink at fractions, use your calculator. Calculator does these really nice. Let me show it just on this one. Okay, so I'm in graph mode, so I'll exit out to a second mode. I'll clear that. Okay, what we're dealing with is 1/5 minus 1. So do 1 divided by 5 minus 1, enter, and you get a decimal, so then you do math, enter, enter. And that gives you negative 4/5. Okay, now we don't want any negative exponents. So if I were to look at this, x to negative 4/5, I'll put it over 1. When we got a negative exponent, we want to move it opposite of where it's at in a fraction. So like this x to the negative 4/5, we'll move it opposite of where it's at in a fraction, so it's up on top, so we want to take it down below. Reason why we do that, if you remember, we got a property from intermediate algebra, algebra 2, says if you take x to a power opposite of where it's at in a fraction, the sign of the exponent changes. So this becomes 1 over x to the positive 4/5. Now here we have a single fraction equal to single fraction, so multiply the top parts together, 1 times 1, and the bottom parts, and that gives us, on the bottom, 5x to the 4/5 power. And that'd be your answer. We'll see a lot more of those. You'll get very used to that. Let's look at this one. Number 5. We got f of x is equal to 5x to the negative 2 plus 4. And we'll find our derivative. So f prime of x. If we have a number out in front, that stays out in front. Take our power, put it out in front. So put negative 2 there. And then lower it by 1. So minus 1. And then derivative of a constant is just 0. So that drops away. So that gives us negative 10 x to the negative 3. Now, you'll get so used to this, you won't have to show all these steps over here. Basically, we had x to negative 4/5. That goes down your denominator. So you could have went straight from this step right here down to here. Again, it's very simple. If it's a negative exponent, put it downstairs. Well, same thing here. We got a negative exponent. I'm going to put it downstairs in denominator. So that'd be negative 10 over x to the positive 3. And that's our answer. Okay. On this one, we got f of x is equal to 3 over 2x to the third. Now our properties are very straightforward right at this point. We got you can have a number sitting there by itself. You can have a number with an x beside it, or you can have x to a power. We can't have this. We can't have a fraction where we have x down in the denominator. Now, if everything is multiplication or division inside of your parentheses, you can take everything to that power. So here we're going to take the 2 to the third power and the x to the third power. Well, 2 to the third and x to the third. That gives us 2 to the third is 8, and we got x to the third. Well, that's a little bit better, but we still need x to a power. Now, remember these previous problems here. We took the x to negative, opposite where it's at in a fraction, became positive. Well, we need to get this x up on top. So we're going to take this x to the third, and we're going to move it up on top. Same property says that you take it opposite where it's at in a fraction, the sign of the exponent changes. So when we're moving up on top, our x to the positive 3 becomes x to negative 3. And then you can actually put it to the side now. And I won't keep showing all these steps, but okay. So again, if you have a number out in front, number out in front stays out in front. Take your power, put it out in front, then lower it by 1. So that gives us negative 9/8. 3 times negative 3. Then x to the negative 4. Well, again, the x in negative 4 can't have negative exponents, so I'm going to take that x in negative 4 and put it down below. So we're going to have negative 9 over 8x to the positive 4. Again, when you move anything opposite of where it's at in a fraction, the sign of the exponent changes. Yeah, let's take a look at this next one. Sometimes you have to do just basic algebra to get it in the right form. Got f of x is equal 5x squared over x to negative 5. Well, we don't want the, for one thing, we'd never want negative exponents down below here. So I'll take that and I'll put it up on top. So that gives us 5x squared, and I take that x to negative 5 up on top, it becomes x to the positive 5. There's nothing left in the denominator, so there's 1 there. And that'll disappear in the next step. X squared times x to the 5th. Remember, you add the exponents. And now it's in the right form. We got x to a power. So for our derivative, f prime of x, the number out in front stays out in front. Take your power, put it out in front, lower it by 1. Which gives us 35x to the 6. And that's our answer. And that might be time for a new page, too. These are rules for differentiation, I think. Yeah, some rules for differentiation. And page 01. There we go. Okay, let's look at the next problem. Got f of x is equal to 6 over 7 and then the 5th root of x squared. Now, we don't have any properties dealing with radicals, so you always put it into rational exponent form, fractional power form. So if I were to rewrite this, this would be x to the 2/5. Whatever number's in this little slot, that's called your index, always goes in your denominator, downstairs. Whatever power is inside is always what goes up on top. Well, that's still not quite right. We want x to a power. We don't want it trapped in the denominator. So I'll take that, put it up on top. So I got 6/7 x to the negative 2/5. And now we're ready to apply our property. Okay, our property says take your power, put it out in front, and then lower it by 1. So we got negative 2/5 minus 1. Well, it gives us, doesn't look like it simplifies at all, negative 12 over 35. X, and this is a mixed number. So we're taking the negative 1 times the 5 gives us negative 5 plus the negative 2 gives us negative 7/5. Now again, we don't want negative exponents. We're going to take that back downstairs. So it becomes negative 12 over 35x to the 7/5. Take it down to the denominator. Anytime you move anything opposite of where it's at in a fraction, the sign of the exponent changes. So the negative 7/5 becomes a positive 7/5. Okay, so we got f of x is equal to 3x squared minus 5x minus 2x to the negative 3 plus 4x to the negative 4. And before we do this problem, let me grab a quick drink because my throat's drying out. Well, this one's in perfect form. Everything's x to a power. So for our derivative, numbers out in front stays out in front. Take a power, put it out in front, lower it by 1. If you have a number with an x, the x disappears. We got negative 5. And this one, the negative 2 stays out in front. Take your power, put it out in front, lower it by 1. On this one, the 4 stays out in front. Take your power, put it out in front, lower it by 1. Well, 3 times 2 is 6. We got 6x. Negative minus 5. Negative 2 times negative 3 is positive 6. X to the negative 4. Minus 16 x to the negative 5. Now, I don't want those negative exponents, so I can always create a fraction by putting it over 1. And again, I'm going to take the x to the negative power opposite of where it's at. So the x to the negative 4 I'll move downstairs. And the x to the negative 5 I'll move downstairs. Put both of them in the denominator. So we got 6x minus 5 plus 6 over x to the 4th minus 16 over x to the 5th. Now we want to simplify this. We'd like to get a, I'm guessing this is what the book's doing. Sometimes they do, sometimes they don't. But if we're going to add or subtract fractions, they should all be fractions. So that's easy. I'll put 6x over 1, 5 over 1. Now our common denominator would be x to the 5th. So I'm going to rewrite each of these with that new denominator. Now this one already has that, so I'll leave it alone. On my first fraction here, I multiply the bottom part by x to the 5th, so I've multiplied the top part by x to the 5th. So I got 6x times x to the 5th. On my second fraction, again, same thing. Multiply the bottom part by x to the 5th, so I've multiplied the top part by x to the 5th. Now this one, I multiplied the bottom part by x, so I have to multiply the top part by x. So that gives us 6x to the 6 over x to the 5th minus 5x to the 5th over x to the 5th plus 6x over x to the 5th minus 16 over x to the 5th. Well, they all have the same denominator now, so I merge them into a single fraction. And I got 6x to the 6 minus 5x to the 5th plus 6x minus 16 over x to the 5th. And that's our answer. And I got room for the next one. Yeah, I should have room for that. Okay, so we got f of x is equal to 7x squared minus 4x times x squared plus 3. Well, we don't have any parentheses in our formula, and everything's x to a power or a number with an x. So what I'm going to do here is multiply everything together. So 7x squared times x squared gives us 7x to the 4th. 7x squared times 3 gives us 21x squared. Negative 4x times x to the squared gives us negative 4x to the 3rd. Negative 4x times 3 gives us negative 12x. Let me rearrange those. So I got 7x to the 4th minus 4x to the 3rd plus 21x squared minus 12x. Standard form, largest power down to smallest. Now to find our derivative. If you have a number out in front, it stays out in front. So 7 remains. Take a power, put it out in front, lower it by 1. Negative 4 stays out in front here. Take your power, put it out in front, lower the exponent by 1. 21 remains out in front. Take your power, put it out in front, lower it by 1. And the negative 12x just becomes negative 12. So we got 28x to the 3rd minus 12x squared plus 42x minus 12. And that's your answer. So let me save that page. There we go. And let's look at the next problem. So we got f of x is equal to negative 2x to the third plus 4x squared minus 5x plus 7. And we're putting it over x. Well, we're looking for x to a power. This is a technique you learned back in intermediate algebra, algebra 2. It said if you have one term down in the denominator and then multiple terms up on top, you can split it up. Put each term on top over that denominator. So I'll put negative 2x to the third over x. I'll put 4x squared over x minus 5x over x plus 7 over x. Now in this one, we had a property from this is x the first down here. We had a property from intermediate algebra, algebra 2. Said if you have x to a power over x to a power, you subtract a smaller exponent from the larger one, and you have x to that power where the larger one was. So this becomes negative 2x squared over 1. Same thing here. 2 minus 1 is 1, so we're going to have x to the first power where the larger one was. On this one, that just becomes 5. And then this we have to rewrite as x to the negative 1. Again, this is a positive 1 power down here, and we take it up on top and becomes x to the negative 1. So we got negative 2x squared plus 4x minus 5 plus 7x to the negative 1. Now let's find our derivative. Okay, number out in front stays out in front. Take your power, put it out in front, lower it by 1. Derivative of 4x is 4. Derivative of negative 5 is 0. On this last one, leave the number out in front. Take your power, put it out in front, lower it by 1. Okay, negative 2 times 2 gives you a negative 4x plus 4. 0 drops away. 7 times negative 1 is negative 7. X to negative 2. Again, we don't want negative exponents, so I put that over 1. And I'm going to take the x to the negative power opposite of where it's at in the fraction. So I'll take the x to negative 2 and move it down below. Now we're going to merge these together. So if I want a single fraction, it's helpful when adding and subtracting that they're all fractions. So I'll put negative 4x over 1 plus 4 over 1 minus 7 over x squared. Now our common denominator would be x squared. So I'm going to rewrite each fraction with that new denominator. This one already has x squared. On my first fraction, I multiplied the bottom part by x squared, so I have to multiply the top part by x squared. So I got negative 4x times x squared. On my second fraction, I multiplied the bottom part by x squared, so I have to multiply the top part by x squared. So I got 4 times x squared. So that gives us negative 4x to the third over x squared plus 4x squared over x squared minus 7 over x squared. Well, they all have x squared, so I'll merge together the top parts. So I got negative 4x to the third plus 4x squared minus 7 all over x squared. And take a look at our next problem. We got y is equal to 5x times x to the third minus 6 over x at 250. Equations or the instructions say find the slope of the graph of the function at a given point. So this is finding the slope of the graph. At a given point. Step 1. Find a derivative. Well, in order to find a derivative of this, we first have to get rid of the parentheses, because we can't have parentheses. We got x to a power, basically, and number, and then number before an x. So I'll multiply the 5x through. 5x times x to the third gives us 5x to the fourth. And 5x times negative 6 over x, the x's would cancel and we'd get negative 30. Okay, so for a derivative, 5 stays out in front, x to the fourth power. Take your power, put it out in front, lower by 1. The negative 30 drops away. So that gives us 20x to the third. Now I'm going to write this in terms of y prime, but it's really whatever notation you have. Change y prime to m, and plug in the x part of our point. Well, the x part of our point is right up here. This is x, this is y, so x is 2. Okay, so we're going to change y prime to m, and we'll plug 2 in for x. Well, 2 to the third is 8, so that gives us m is equal to 160. That would be the slope of our graph at that given point. Pretty big slope, but that's our answer. Let me save that. There we go. Let's take a look at our next problem. This one says, find an equation of the tangent line. So we've got 13. And we've got y is equal to 2x to the third minus x at negative 1, negative 1. And this is finding the equation of the tangent line. Okay, step 1. Find a derivative. Well, take power, put it out in front, lower it by 1. Now the negative x is like negative 1x, so the derivative of it would become negative 1. So that gives us 6x squared minus 1. Step 2. Change our notation, in this case y prime, to m. Plug in the x part of the given point, and simplify. So for this right here, this is y prime. So it says change y prime to m. Now the x part of our point is negative 1. So I'm going to plug negative 1 in for the x and simplify. Well, negative 1 squared is a positive 1. So we got 6 times 1, which is 6. And 6 minus 1 gives us 5. Well, step 3. Into y equals mx plus b. Plug in the given point for x and y, and m from step 2, and solve for b. Okay, so we got this right here, y is equal to mx plus b. Now m is 5 from step 2. Now if I go up at the top, plug in the given point for x and y. Well, this is x and this is y, so I'll plug in -1 for x and -1 for y. So we come down here, -1 for the y, -1 for the x, and then solve for b. Well, 5 times -1 is -5. Take -5 to the left side, becomes a +5. And we get b is equal to 4. A lot of people forget to actually write your answer. Your answer is the equation of the tangent line. So you plug in your m from step 2, which is 5. So that becomes 5. And you plug in your b from step 3, which is 4. And our answer is y is equal to 5x plus 4. And I don't know if I have room for the next problem there, so let me save this. There we go. And let's look at the next problem. Now I believe it's using the exact same steps. Yes, it is. Okay. So we got f of x is equal to 1 over the cube root of x minus 3x at 1, -2. So, okay, we're going through the same steps. Our first step is to find a derivative. Well, we can't have any radicals, so I'm going to rewrite the cube root of x as x to the 1/3. Now remember, whatever number's in this little slot here, that's called your index. That goes in your denominator, downstairs. Whatever power's inside, and if there isn't one, it's by default 1, goes up on top. Well, that's still not quite where we want it, because we want x to a power. But we can take this x to 1/3 and move it up on top. And that's going to become x to the -1/3 minus 3x. And we're now ready to find our derivative. Take your power, put it out in front, lower it by 1. So we got -1/3 minus 1. Derivative of -3x gives us -3. So that gives us -1/3 x. This is a mixed number. -1 times the -1 at the end. -1 times 3 gives you -3, and add the -1 gives you -4. So we got -4/3 minus 3. Again, we don't want negative exponents, so I'm going to take that back downstairs. So I got -1 over 3x to the +4/3 minus 3. Okay. Step 2. Change your notation, your f prime of x to m, and plug in the x part of our point. Well, if I come up here, the x part of our point is 1. So plug in 1 for the x. So I got -1 over 3 times 1 to the +4/3 power minus 3. Well, 1 to any power is 1, so that's going to drop away. So that gives us -1/3 minus 3. Well, this is again a mixed number. So I'm going to take -3 times 3 gives me -9 and add to 1, and that gives us -10/3. Okay, step 3. Plug in the given point for x and y and plug in the m we just found. Well, the m we just found was -10/3, so I'll go ahead and put that in. Let's go see what our x and y are. Okay, x is -1 and y is -2. So let's plug those in. -2 for the y and x is 1. Well, -10/3 times 1 gives us -10/3 plus b. Take -10/3 to the left side, becomes a +10/3. Well, this is a mixed number. So I take -2 times 3 gives you -6, and then you add 10, and that gives you 4/3. And now we can't forget our last step. We actually got to write our answer down. I forget what m was. Probably -10/3 from the way that looks. Okay, step 2, m was -10/3. So we got y is equal to negative 10/3 x, and b was positive 4/3. And that would be our answer. That's the equation of the tangent line at that given point. Let me save that, and we'll look at the last problem. There we go. And here we're given y is equal to 2x to the third minus 21x squared. Now this is to find out where we have horizontal tangent lines. And this can become important later on. Let's say I'm looking at a graph, and it looks like this. Well, if I look at the tangent line here, it'd look like that. Use your imagination. This would look like that. When it reaches the very top here, it becomes horizontal. So it's a horizontal tangent line. And then over here, it starts going down like that. We're going to find horizontal tangent lines oftentimes tells us mins and maxes and so forth. So that's where we're headed with this. But the instructions, only thing here says determine the point, if any, at which the graph of the function has a horizontal tangent line. So these steps are finding the horizontal tangent line. Step 1, find our derivative. Geez, that's pretty sloppy. Let me try that again. Okay. Find the derivative. Well, on this one, take your power, put it out in front, lower it by 1. So we got 2 times 3x squared minus 21 times 2. Take your power, put it out in front, lower it by 1. So that gives us 6x squared minus 42x. Step 2. Set the derivative equal to 0. And solve. So we set the 6x squared minus 42x equal to 0. Now we want to factor out the GCF. They both have a 6 and an x in common. And that leaves us x minus 7. Zero factor property. It says you get 0 on one side, you factor the other side, you're going to set each factor equal to 0. So I'll set a 6x equal to 0 and x minus 7 equal to 0. On this one, divide both sides by 6. And we get x is equal to 0. And on this one, take negative 7 over and we get x equals 7. Step 3. Plug in each x value into the original function to find the y values. Okay, so we got x is equal to 0 and we got x is equal to 7. Have no clue what our original function was. Let me go up here and look. 2x to the third. Actually, I guess I can go to the PowerPoint here. Maybe. 2x to the third minus 21x squared. So again, we're going to plug each one of those x values into our original function and find out what the y value is going to be. So over here, I'll plug 0 in for the x. So I got 2 times 0 to the third minus 21 times 0 squared. 0 to the third is 0, times 2 is 0, 0 squared is 0, times 21 is 0, so 0 minus 0 gives us 0. So our first point is 0, 0. Our second one, we'll plug in a 7. So I got 2 times 7 to the third minus 21 times 7 squared, which gives us 343. So 2 times 343 minus 21 times 49. 686 minus, this would be assuming I can actually multiply, which is questionable at times. 1029. Yeah. Okay. So then we want to subtract 686 from that. So that gives us 3 there. Need to borrow, so that goes to 9. This goes to 10. This becomes 12, so I got 4. 10 minus 6 is 4, and then 9. Why am I writing so sloppy? I know I screwed that up. Let me try it again. Okay. This was 1029. We're subtracting 686. Make it a little bit neater. That gives us 3. I want to borrow, so that goes to 0. This is 10, and we borrow 1 from it. That becomes 9, 12, 4, 3. 9, 12. Yep, that should be right. If not, we'll pretend it is. So negative 343. So that particular point there is 7 and negative 343. Now, some of you have heard me talk about this. Why do this by hand over here? Because it is so easy to make a math error. I had a professor at Wichita State one time, and he explained he always did these over an aside by hand. And he explained one class. He said, "Man, I wonder why I do these by hand. Don't just use a calculator." And we all did think that. We thought, well, you need to move forward a generation and start using a calculator. He explained. He's done a lot of research, and by doing this basic math like this helps stem off Alzheimer's. And I believe it. He's in his 70s and still teaching, just sharp as can be. And he said Alzheimer's runs in his family real bad. Now, my mother had a little bit of Alzheimer's, so I keep thinking I need to start doing this more and more to help keep my mind sharp. Now, algebra itself doesn't do that, but it may cause Alzheimer's. But basic math like that helps. So anyway, I think that was the last problem. Yes, it was. So let me save this page, otherwise I'll forget. And then stop the recorders. There we go. And stop this other one.